So now I will complete the wall, for example, for the course, the leaf. And adjusting, I will finish. We can also erase these elements that we don't need. And a 3D view will show us the advance of our project. Okay, so right until this moment. So now we need to complete the different contours, the perimeters, and we need to complete that with the beams. So to introduce the beams, we will go to the menu beams. We can define beam. We have this menu where we can see the family, so flat beams, drop beams, foundation beams, steel beams, timber beams, etc. And for every family we have different types. In this case we will use the rectangular drop beams, but as you can see we have the other choices too. We have, for example, the T-beams, inverted or inverse T-beams, or for example the inverted rectangular beam. So we use for our project the rectangular one, and in this case we will use the width of 30 centimeters by a depth of 45 centimeters. We can accept, and we will use a very interesting tool on our program that's called Snap. From this DWG file, the architect, or saying the user of SAPECAD, have already defined a polyline following the contour of the building, and the program with this tool Snap can follow this polyline with the beam. So I approach to this polyline with the definition of the beam, and clicking left, you will see that the program follow this polyline defining and these elements. So I will go on this case to the next level. That is very, very important. You know that I am on the foundations, but I can go to the next step. It's next floor, next level, it's the floor. And here I will sketch, and I will repeat the same process. Now it's the correct level. So we have the perimeter. We need only to complete the different elements that make the function of support of the slabs. So to complete the position of the different beams, we can use this tool that is extend beam, and we can extend some of the beams to complete the geometry of our building. If we need to define other beams, we can go once again to define beam, change to the tool simple, and we can go approach to the column, and you can see a red point. This red point, this red circle, mean that an element or it's detected to define the position of the beam. We can position the initial point of a beam on a column, on a wall, or, for example, on this case, on other beam. Okay, so I will go to this column. We have different tools. For example, in this case, I will use the orthogonal. To complete the support of the beams. We have a rack here, and you can see that the beams have limited the section of the wall. So now we can delete the elements of the wall that we don't need. Okay, and now we complete the other beams. A 3D view will show us the advance until this moment. Okay, we can see the different columns, the walls, and the slab or the virtual slab that the program defines when a contour is closed. So now we can go to the slab panel manager. We can define a panel, and we will use this tool later to define the walls, the slabs. Sorry. So at the beginning of our presentation, we talk about the shear walls and the coupling beams. So until this moment, we have here the different walls, but we don't have elements with the necessary dimensions to be a coupling beam. So we will define on this position the necessary beams to be a coupling beams. So for this, we will go to beams, define beam, and we will tape the depth 100 centimeters. We can accept, and we can approach to the end of the wall and going to the next wall. We define these beams that will manage like a coupling beam. Okay, so how we can show to the program or define to the program that this element have different characteristics or different features from the others. So on this case, we have on the menu walls the tool assigned to act as a shear wall. On CyberCAD, the model is managed by finite elements, and the reinforced concrete is obtained point by point of these finite elements. But if we need to integrate the forces, also check the different values that is needed to do with the code. In this case, for example, we can apply, or we need to apply an earthquake load, and these elements will be an different features, or will have special characteristics. So to show that to the program, we will go to walls and assign to act as a shear wall. In this case, we can define the name, define a number, and we can assign to select the different elements that will act like a shear wall. This information and this geometry will be exported to the BIM server center, and after that imported on the program shear walls and StruBeam shear walls, and will manage like that. So next element, next one, the core of the leaves, and the core of the leaf on the right. So these are the elements that we have selected like a special element. Okay. And you can see the coupling beams that will be selected too. How we can select these elements here in define coupling beams and assign for these beams this feature or this characteristic. Okay, so after to design and select all these elements, we will complete our floor with the slabs. Here the user have different options for the joist floor slab, composite slabs, waffle slabs. The user can also use the mat foundations with the soil resistance and subgrade modulus. For our example, we will use the flat slabs. It's the simplest. We need only define the depth. Accepting this menu, we will go to the workspace to click on the close perimeter, and clicking on this beam, I will take the direction of the axis to define the direction of the reinforced bars. And we can copy panel, and selecting by window, copy these elements to all the others. Okay, so I think we have the model for this floor complete. So now we will come back to the column definition and we will go to the floor, new floors. We can select this level. We will define single floors, and we can define an height of 3 meters with a live load of 0.20 tons over a square meter and dead load 0.2 tons over a square meter. We can repeat these values 9 times, and accepting, we can pass to the next sheet BIM definition, and we will show the result of the action on a 3D view. So, and remember this is our primary structure. We need only complete, on this case, the foundation. The foundation will not be our start today, but I will only show how we can define the foundation. So on this case, I will switch off the information of the plans, of the drawings here, and we can go to the menu foundation elements, and we can define a new element to see the different options. So we have footings, we can have also pile caps, and we can define with this little footing, it's in this case the arrow of the mouse, we can click in left position the footing for the single columns. We can also define for these walls a footing, and for this element that will be combined, I can right click, and we can select multiple column elements. We can accept, and this time I will select by window 2 columns. Clicking right, I will finish the selection, and the mouse, the arrow of the mouse, come back once again a footing, and I can click left to define the foundation. Repeat the process here, and a footing is defined for combining the two reaction of the columns. For the walls, same way. We can also remember, we can define the beams, the strap and beams. This is more or less the process. It's a very friendly process. We have different tools in order to define all these in the very fast way and a simple way too. Three view. And we have our primary structure defined. So we can see on the slides that we need to define a secondary structure with SIFE 3D. And why SIFE 3D and not SciPCAD? SciPCAD is the program that I am managing here. It's a program that focuses or concentrates his forces and his strong point on buildings. Buildings are composed generally by vertical elements like columns and walls, and horizontal elements. In this case, for example, walls, beams, etc. So, when the geometry is more complex or there are different bars in the space, we need other tool. But this other tool that is SIFE 3D can work integrated the strong point of both programs. So how can use SIFE 3D integrating this structure or this complex geometry on a primary structure of SciPCAD? We can see here the menu 3D structures, and we can go on the level we need to define a different geometry. Go to this menu, we can define new structure, and we will define some connections. So we will define other structure will be connected with the primary one. So I will define, in this case, these 4 connections. I will click right, validate these connections, and we will obtain, on this case, the workspace of SIFE 3D. For this case, I will have different tools from SciPCAD that will permit me to define geometries more complex and different type of geometry that on SciPCAD I cannot be able to do. So for this example, I will show how to define this kind of structure. Tetrahedron, very spatial, and an important number of bars. This case sometimes appears on our buildings, where we have a primary structure on the reinforced concrete, and we'll have different secondary elements in order to complete the functionality of the building. So I will complete our primary structure with the secondary one, and we can start with the definition of the bar. We have here different type of material selection and section selections. For our case, I will use the cold form steel section. In this case, a circular one, and I will use from the commercial series, the 512.1. We can accept, and connecting this initial point to a second node, I will define 4 columns. on steel. And after that, I will define the spatial structure as we see on the image. For this structure, I will use a circular section of 3 values, and I will use these elements to the generation of the structure. So, define these main elements. I will use a tool of the program that is called generation, and I will generate a tetrahedron mesh. I need to define now the beginning of the generation, the axis 1 for the generation, the axis 2 for the generation, and we have here a draw remarking the different steps and the different elements that will be compose this generation. So for this axis 1, I need to define the segment divisions. Remember that we have here 10 meters. Maybe I pass very fast there, but you can believe me. We have 10 meters. And for the second one, I have 5 meters. I will divide, so this bar on 5 elements. And the distance between planes will be 1 meter. We can accept. And we have the structure. Now I need to, these are elements that don't have defined yet the section. So I need to go to describe, and I will select all the elements in order to define his section characteristics. We can go to Tools, 3D View, Complete the Structure, and we have the structure. If I need to extend this structure to both sides, on both directions, I will use different tools from the program to do that. Okay, so the user can use these different tools not on the same way, but on different way to define geometries of his projects. So I go to this little menu to obtain different combination of direction of axis, and I can see in a 3D view from a side. Okay, so to extend this spatial structure to both sides, I will go to the menu Tools. I will copy elements. I will select nodes and bars, and selecting by window, I will copy these elements for both sides. I will have, maybe I have much more information. So, and now I will repeat the action for the other side. As you can see, I extend the structure to this side. So, and now I will repeat the action to extend for the other direction. Selecting the elements, selecting this one too, and now to the side. Repeat, copy elements, and now a 3D view of the complete structure. So we have our structure. On Site 3D, the self-weight of the elements is taken into account automatically, same way that on SciPCAD. But if we can, if we need to, for example, add some loads, we can go, for example, to the menu load, introduce loads on bars, or introduce loads, for example, on nodes. We can select, for example, all the nodes of the top surface, of the top plane, and we can, for example, define a mid load of, for example, 100 kilograms in every point. We can go to the menu load to change the scale. I know that it's a very little load, so I need to change the scale in order to see with more detail. And as you can see, I add the different loads to every point of the element. We have the self-weight too, as you can see. The self-weight of the bar is taken into account automatically by the software. So now we can come back to the primary structure on the workspace of SciPCAD, and obtaining a 3D view, we can see the primary structure and the secondary too. Okay. So if the model is complete, we can close, we can save the model, and we need to complete the process, go to the analyze and launch the analyze. At the same time that we launch the analyze, we will obtain the discretization of the structure, and we will obtain the forces, stress, and the sign of every section. So in order to save time for this demo, I have the complete model with the results. So I will open this complete model with the results, to show you how we can control the results and edit the different sections, and the process to export all this information to our platform, BIM, to the platform BIM Server Center, and import all this information, the necessary information, to the stream sheet world. So here we have the complete model with the result. Generally, the user have different tools to control the result. These tools will be available on the sheet results and on the sheet contour maps. Okay. Generally, the first step that we make, like user, at the end of the analysis and the design, we go to, and I said generally because people have different habits for that, but generally I will go to the deformed shape. For me, it's the better way to obtain to see the behavior of the building for the different load cases. So we have the discretization. We can view the structure to superpose, overpose to the model. We have, for example, here the possibility to see different information for the displacement on the screen. Okay, so we can, for example, go to a different load case. We can exaggerate just a little the factor, and we can see, for example, the displacement for the secondary structure, for example, and for the secondary one. These different load cases will show the general behavior of the building. We can also obtain the view structure, and we can see different values. So the next step, generally, I will go to the contour maps. For the contour maps, we have different tools, and we will control on the result of the floor. When on the first deformed shape, the first control that we can make is the general behavior. And in the case of contour map, I will control the behavior of every slab, okay, and floor by floor. So generally, the tools here are designed to control the result and the behavior of the slab. So we have, for example, here the ISO lines, the ISO values. We can see, for example, the displacement. We can control here the deflections. We have the tool deflection. We can see on the general view of this floor the points that we have the deformations, the most important, and we can control the values going to this tool deflection between 2 points, and we can define these 2 points, obtain the result for the deflection and the absolute value and the relative value for the length. Okay, so in this case, it's the user that can control if this deflection is over or under the limits that in general code makes some advice. So if the deformation is over the limits, the user needs to modify the model in order to obtain less deformation than the initial one. So to control the, on this case, the forces and some other values, we can, for example, go to this little tool that is very, very interesting for me, because I have so much information with this little tool that we can select a strip width of 1 meter, for example, go to one of the forces that is interesting for us, for example, the moment, and we can select, for example, the load case or a combination, for example, and selecting a direction for the slab, I will obtain all the forces integrating in this strip of 1 meter and obtain the maximal and minimal values. With these values, I can go to other tool to verify or to obtain a control over the reinforcement that the program obtain. So, like I can show you that the program design the section, but if I want to control or to verify this section, I can obtain the forces, and by hand or for another with other tool, I can check this section of the design. That is for me very, very interesting. So other tools that we can use in order to control the result. Remember that we have the edition for every element that we define on our project. For example, we can follow the weight or the path of the different loads. We have the behavior of the entire building. We have after that the contour map, and now we can go to the beams. So we have here for every beam and every frame the results. We have so group by group the different frames with a plane view of this frame. Okay, we can see on this case we have the frame 2. We have the force diagrams. We can see the persistent or transient forces or the seismic ones. We can see these forces superpose, overpose on the frame or below the frame. We can obtain the different values. Okay, following the frame, we obtain the values of the forces. And as you can see, we have also the reinforcement. So for the reinforcement, the user can also edit the proposed reinforcement that the program made. In this case, this section is automatically proposed by the software with the analysis and the result of the different stress and the code also. And the user can came here and change, for example, the the section. So after edit the section, the user can go to this little button, update errors information, and you can see one red point, one red circle showing so as a warning.
Kulihatkan juga fotomu nggak dia. Maksudnya
remark that the section that we edit have an warning or an error. If I need to, or I want to obtain a detail of the section, of the error of the section, I can go to the ULS report, select the section, and we can obtain a detail of all the checks that the program apply to this frame. All these reports can be obtained in different formats. Okay. And it's very, very detailed. I love this report. It's the best way to communicate the result of our project. Nothing is hidden on this report. You can every time go to this report and see what the program applied for every section of the frame. That is incredible. So we can apply some different characteristics for this frame or for this beam. We can edit the longitudinal reinforcement. We can see below this part or this part of menu. For example, I will select only this part of the frame. I will show that this element, this part of the graphics, show us that in red we have the necessary section for the beam, and the green one is the section applied for the section, the reinforced section. So, in this case, we can see that the necessary section is bigger than the real one. So, it's for this reason that we have an error. We can come back to the original values, and now we can see the green line over the red one. So in this case, we don't have a warning. So we can update error information, and we can see that all the checks pass the values or the necessary limits from the code. So other interesting tools on this edition, for example, the openings. We can apply openings to this beam. We can apply, for example, to pass some pipe installations or something. We can position this element and to apply this reinforcement, and after that the program will apply the checks to know if the new section, the section, the deleted section, pass all the checks or not. Okay. that is very, very interesting. So now we can go to the columns. For the columns, we have also a similar menu, especially designed for the columns, obviously. Sorry. So we have the different floors, the section, we have the longitudinal reinforcement or on the corners, on the X face, Y face, and here we have the drawing or the different position of the reinforcement for the bars and the stirrups and transversal reinforcement. We can edit every value of all these. We can propose a different section. We can, in a drop-down menu, select all different section for the reinforcement bar. We can modify also not only the diameter of the bar, but also the number of the bars. I can apply, for example, 4 on 4. For example, here you can see. And now, for example, I can modify and apply other kind of stirrup. Okay, so all this is possible made to the software. And after this edition, I can pass the code checks to know if my edition passed all the checks or not. You can see all the checks pass. If I need to have more information about the different combinations, the different load cases, we can also obtain more detailed information here with the surface. We can also obtain all the combinations. We have page and page of information to know every detailed section of the column. And remember that we can also see the different forces. Okay. And we can see a 3D view. All this information will be available on different formats. We have programs to manage all these. But if we can go just right now with a 3D view, for example, and DXF or DWG format, we can export all this now with this format and obtain information that can be useful for the user. For every column, we have, for example, the possibility to obtain, for example, the code checks. Remember that the program make and pass all the checks, not only for the forces, but for the code too. In this case, this important check for the strong column and weak beams, the check for the node is made automatically by the software and with the real reinforcement, not with the necessary. That is very important too, because it's most exactly made the different checks with the real section of the reinforcement, and all this is made automatically made by the software. We have the export to the different formats, and we can see a page preview with we will show you a preview of the report.